Just making a video here on footings number 1, so column footings and strip footings. Just using the code book to get the numbers, and then from there work out the size of the footings required for the given questions. So what is the size of a column footing for a 42-foot long 2-story house that has 3 posts supporting the beam? Column plate is 6 inches. So basically a little sketch there might kind of help us to kind of get through that. So a little sketch there. The building is 42 feet long. So the beam is running down the center here. We're told that there's 3 posts. We'll just sketch those in. There's post 1, post 2, post 3. And then from there, we can tell that there's 4 spaces. So basically what we have to do is we have to determine if we kind of meet code, right? Code allows a, just putting on headphones here, so let me try to make the sound a little bit better there, but so by determining the on-center spacing, we'll then know if we meet that 10-foot rule. If not, we then have to increase 10% for every foot that's over 10 feet for on-center spacing. So we're going to go ahead and we're going to determine the on-center spacing for the post on this building. So we're going to take the length of the building and then we're going to divide it by the number of spaces. So if we take the 42 feet and then divide it by 1, 2, 3, 4 spaces, we'll then have our on-center spacing. So 42 divided by 4 gives us 10.5. So 10.5 feet. So that means the distance from outside the foundation to center of post is 10.5. Center post to center post is 10.5. Center post to center of post is 10.5. That's all feet. And again, center post outside the foundation, 10.5. So by code, to be able to follow the numbers coming out of the code book, that distance cannot exceed 10 feet. If it does, we have to increase 10% for every foot. So basically right now we're half a foot more. So we could look at that as being basically 0.5 of a foot increase. Therefore, we require to have a 5% increase. So 5% is the same as saying 5 over 100, which basically means 5 divided by 100 is equal to 0.05. Okay, so that's kind of the number there that we have to use to multiply our area. Okay, so if we look at the question, we're told it's a 2-story building. So if you're following our notes, we know that for a 1-story building, it's 4.3 feet squared for the area of a column footing. So the area, which is basically the top surface of that column footing. Right, so the code book is telling us how big is the top surface of the footing. From there, we need to then also know the thickness. Okay, but right now that's what's given. So for a 1-story building with an on-center spacing not exceeding 10 feet, the area of the footing is 4.3. For a 2-story, the code book tells us 8.1 feet squared. We'll take a look at the code book in a second to see where that comes from. And then a 3-story is 10.8 feet squared. Okay. So if we open up the code book, so the one we need is this one right here. Right, we need 8.1, which is good up to 10 feet. We're beyond that by 0.5 feet, so we have to enlarge that area by 5%. Okay, we'll worry about that in a second. Let's just have a look at the code there. So if we grab the code book here, so the 2012, okay, we're going to go into table of contents, which is just at the beginning here of, that's part 9 right there. That's division A. So at the beginning of division A, there's actually a table of contents there, which we're going to have a look at. So we can see part 9 over here. So I'm trying to see if I can zoom in better there. Not very clear. So anyways, part 9, there's subsections there, right? We got 9.4, which is structural, 9.5, design area, 9.6 is glass, 9/8 stairs, right? We use that one quite a bit. 9/12 excavations. And then we get to 9/15 footings and foundations. So we're looking at right now is footings. So if we go to 9/15.3, so part 9, section 15, which is footings and foundations, subsection 3, which brings us to footings. So don't look at the page number, look at the section number coming from the code book, right? Because this can vary depending on the size of the page of the code. So if you had a code that was maybe in a binder, there could be less pages or more pages depending on how big the print is. So always go by the section number. That tends to stay the same unless they add stuff to the code, which might just move things around slightly. So let's go look at 9:15.3. So we're going to go into part 9 now. So part 9 now is that wider section here. So we're going to go into that. Under, see, there's 9:25. We want 9:15 and then 3. 20, 18, 17. It's getting pretty close there. So 9:15.3 is right here. If we kind of look through footing required, supporting a footing, basic footing width, end area. That's what we want right there. That's the chart that we're looking for. As you can see, I kind of went ahead and added these 4.3, 8.1, and 10.8. But if you look at the chart, right, so minimum footing sizes, number of floors, 1 floor, 2 floor, 3 floor. Here we have minimum width of a strip footing, so exterior walls, interior walls. And at the far end, minimum footing area for columns spaced 3 meters, which we basically round up to 10 feet, on center. And this answer here is in meters squared, so that's 0.4 meters squared, 0.75 meters squared, and 1 meter squared. I converted that, right, because the things that we're doing are typically in imperial. But the way you would convert that is basically looking at meters to feet, okay? So I'm just going to grab a scrap piece of paper there. But if we're going from basically 1 meter is equal to 3.28 feet, okay? So you kind of need to know that or search that. Again, a lot of calculators, a lot of phones have conversion tables on there that we can easily convert that. I'm a firm believer you should try and memorize some of those things. One way that I was able to keep that in my brain was by knowing what a Canadian shingle is, right? A Canadian shingle is actually 1 meter. So if you've dealt with shingles a lot, if you measure them to do layout and stuff like that, or estimates, I kind of remember that it's 39 3/8 is the length of a shingle, right? So a Canadian 3-tab shingle, not the architectural ones, the 3 tabs. So that is basically equal to 3.28. So if I went 39.375, that's exactly what we have there, and I divide that by 12 to put it into feet, I end up with 3.28125 feet. So that's the number there. That's kind of lined up. So that number there I kind of knew as an apprentice. Then being a teacher, I then somehow kind of memorized that number there. Okay? So knowing your product, right? Knowing your materials is something that you need to do as a carpenter. You need to know certain things. You know, like some trades, like mechanics, for example, they need to know the size of a bolt or size of a wrench. They should be able to look at a bolt and determine what wrench they need just by looking at that. Well, it's the same kind of thing for us. We need to know what dimension of some things are. We need to know what a 1/2-inch plywood looks like. We need to know what 1.5 inches looks like just by looking at it. So same thing with that, right? Knowing that a shingle is 39 3/8. If not, memorize it in some shape or fashion. But basically, if I had 1 meter squared, what I'd have to do is use that number times itself, right? So if I'm trying to go into feet squared, I'd have to convert that by multiplying by that number to the exponent of 2. So 3.28 times 3.28 would then give me my multiplier. Okay, so if I have 3.28, I just press x squared, I end up with 10.7584 feet. Right? So that's kind of the conversion, feet squared. So 1 meter squared is equal to 10.7584 feet squared. So if I had an answer over here, like if you look in the code book, right, now I have the number I need. That's the number I need to multiply by. But if I look in the code book and I have 0.4 meters squared, if I want to put it into feet squared, I multiply by 10.7584. And I'm going to get an answer there in feet squared. Right, so if I take the 0.4, multiply by 10.7584, plus equals, I got 4.3 there. So I'm only going to take 2 decimals. So it ends up being 4.3. Okay? If I were to do the same now with 0.75, so 0.75 times 10.7584, I end up with 8.1. So if I rounded that to 2 decimals, I have 8.1. And then if I take the 1 meter squared, multiplied by 10.7584, I end up with, if I round to 2 decimal places, I could say 10.76. Okay, so I just rounded that to 1 decimal there, so 10.8 feet squared for the area of a 1-story, 3-story, right? So the area of a 3-story column footing in the basement. Okay, so kind of knowing how to convert there. So you can see I kind of went ahead and I just made those modifications. Probably a good idea to know where those things come from. So again, base it off of the individual unit to the individual unit. So meters to feet, from there exponent of 2 on that standard number, then gives us the multiplier to then get the equivalent. Okay? So if we go back to that question now, it's over here. Okay, so we basically determined that the on-center spacing is over 10 feet by 0.5 feet, right? So 42 divided by 4, which gave us our on-center spacing of 10.5. Code is up to 10 feet, right? These numbers here are up to 10 feet on-center spacing, okay? So we're 0.5 higher than that. So by code, we have to add 10% for every 1 foot over 10 feet, right? So every time we're 1 foot over 10 feet, we add 10%. So in this case, we're only 0.5 feet over, so it's basically half of that, 5%. So that's our multiplier. So what we have to do is find a new area, right? The area of 8.1 for a 2-story building is good up to 10 feet, so we need to modify that number by 10% for every foot. So we have to multiply by 1.05. So why do I have the 1 there? What the 1 is going to do is it's going to include the 8.1 in my answer. Right? So the 0.05 is going to find how much larger is it, right? Or by increasing it by 5%. But the 1 includes the original number. So if I go 8.1 times 1.05, I'm going to get my new area based off of the increase because of the extra 0.5. So 8.1 times 1.05, we end up with 8.505. There is our new area. Okay, so that's the new area now for that building. So we have to determine basically a length and a width. Okay, 2 dimensions. Area starts off by having 2 dimensions, right? Length and a width. So that's what we need. So if we took that number there and square root it, we're going to get 2 numbers that are equal to each other, which is what a column footing. Column footing is a square. So if I square root 8.505, I'm going to end up with an answer there in feet, right? So if I square root something, let's say I square root something that I know. So I basically know 81, right? If I go 9 times 9, 9 times 9 gives me 81. So if I want to square root 81 now, so square root 81, the answer would be 9. So if I square root something, I'm going to get a number multiplied by itself gives me that original number, which is what I want. I want 2 numbers that are going to be identical to each other, which then multiplied by each other will give me the area required by code. So if I square root 8.505, I end up with a number there in feet, so 2.9163 feet. I want to put that in inches so I can actually work with it, so I'm going to multiply it by 12, which then puts it into inches. So multiply that by 12, leave all the decimals there, and with 34.99. right? So 34.995, let's say. So if I want to put that into fraction form, the first thing I would do is take the 34, write it down, subtract that out of the calculator. I'm left with fractions of an inch. I want to find out what that is over 16, so I multiply by 16. That gives me the numerator. If that number beside is 5 or higher, I bump that up to 16. So it basically would be 16 sixteenths. So that's not proper. That's a whole inch. We just add it to the whole inch columns, and then we get 35. So what we just determined is the length here is 35, and the width there is also 35 inches. Okay? So we have that. Now I can write that down over here. That's 35. That's 35. Still need the thickness though. So where the thickness comes in, we have to use this number right here. Column plate to 6 inches. So there's actually a plate that sits on top of the column footing, and then from there the post sits on top of that. So the plate, we're told, is 6 inches. So what we want to know is, what is this distance from here to here? And what is that distance from there to there? We're going to call those P, which is projection, okay? So basically, we could come up with a fancy formula, or we could just look at the drawing. We know that the distance from here to here is 35. The plate occupies 6 inches of that length, and then we need 2 equal spaces on either side by having that plate centered. So if I went 35 minus 6 divided by 2, I'd get the projection. Okay? So if we wanted to put that into a formula, we're going to call, what we're searching for is the projection. We're going to call that the footing width. And we're going to subtract the plate. Put that in brackets, and then we're going to divide by 2 equal parts. Okay? So the footing width is 35 inches minus a 6-inch plate, and we're going to divide that by 2. Right, so 35 minus 6 divided by 2 gives us 14 and a half. 14.5 inches, which is 14 and a half inches. So what we just determined is that from here to here is 14 and a half. Okay, and the code book basically tells us that the projection, or the thickness, so the thickness is greater than or equal to the projection. I'm kind of writing a lot on this paper there. I'm just going to put that as a rule of thumb. Right, so the projection, right, is going to kind of dictate the thickness. So the thickness of the footing has to be equal to or greater than the projection, and minimum of 4 inches. So if we do this, if we take the projection, and the projection is less than 4 inches, automatically we have to make the thickness of the footing 4 inches. That's the bare minimum for the thickness of a column footing, as well as the strip footing. So basically, if this is 14 and a half, this has to be 14 and a half or more. Right? So if we follow that, once we have the projection, we also have the thickness as long as it's more than 4 inches. Okay? So I'm going to write down 14 and a half inches there, and I'm going to write it down in my answer. So I got lots of writing down there, but hopefully that all kind of comes together to make sense. So I'm a big believer in looking at the drawing, try to work off the drawing. So 35 minus 6 divided by 2 gave us the 14 and a half. Okay. Moving on to the next one here. So the next one is a strip footing. So strip footing required on a 2-story house with a full concrete structure and a brick veneer. Okay, so a full concrete structure with brick veneer. So meaning it's basically a masonry construction of some sort. And then there's a brick veneer put on top of that afterwards to kind of hide the cinder blocks, or it could be poured concrete. There's also a 10-inch foundation wall sitting on top of that strip footing after the fact, which we would need to get the thickness. Okay? So basically we have a foundation wall. It's sitting on top of a footing. We know that the foundation wall is 10 inches in thick. What we have to find is, what is this footing width based off of code? So we were already looking at that chart in the code book, right? So 915.3 is where we needed to be. So I'm going to try to get back to that location without going to the table of contents. So 915.3. There it is right there, okay? Make sure we can see that on the screen. We're talking about exterior walls, strip footings, right? Strip footings for exterior walls. So 1 story is 250, 2 story is 350, and a 3 story is 450. Okay, so we're talking about a 2 story right now. So it starts off as 350. But it also says notes to table 915.3.4. Take a look at sentence 915.3.7, sentence 1, or sentence 915.3.5. So if you kind of have a look at those numbers there, right, there's 915.3.5, which is the second one here. And if we read what it says, adjustments to footing widths for exterior walls. So if that's a standard footing for just a wood frame construction with siding or stucco on the building, right? If there's different materials put in place, that footing needs to be made larger to accommodate the extra weight bearing down on it so it doesn't sink into the ground. So if we read through this, so strip footings width for exterior walls exterior walls shown in table 915.3.4 shall be increased by 65 millimeters for each story of masonry veneer over wood frame construction supported by foundation wall. B, 130 millimeters for each story of masonry construction supported by foundation wall. And C, 150 millimeters for each story of flat insulated concrete form, so ICF, wall construction supported by foundation wall. So in our case, so we've got to remember that 65 millimeters for each story. So we have a 2-story building. So I'm just going to grab that paper there, see if we can kind of look at both at the same time here. I wish this was clearer. Very, very fuzzy, but so we're looking at full concrete structure, which is basically masonry construction, right? So it says that's the first thing we see, right? So the first thing we see is masonry construction basically for 2 stories. So we're going to have to go plus 130, plus 130. Initially, it's a 2-story building, right? So under a 2-story building, we see 350 here. So 350 is our initial footing size. We increase these here for masonry construction. And then we have also brick veneer. So we have brick veneer 65 millimeters for masonry veneer over wood frame. We're not over wood frame, but we're going to allow for that just to make sure. So we're going to add on 65 millimeters for 2 stories of brick veneer. Okay, so the brick veneer is added on top of the masonry construction just to be sure that we're strong enough there. So these are all in millimeters. Right, so they're all millimeters. So we're going to have an answer down here in millimeters, and then we're going to have to convert it because our answer needs to be in inches. So if I add all of those up, so 350 plus 130 plus 130 plus 65 plus 65, we end up with 740. So 740 millimeters is the distance from there to there. We have to convert that to inches. So knowing that 1 inch is equal to 25.4 millimeters will be our conversion. Right, so if I have millimeters, if I divide by 25.4, it's going to give me an answer there in inches. So I still have the 740 in my calculator. I'm just going to divide by 25.4, which then gives me 29.1338 inches. So that's 29. So we're going to have 29 inches. So subtract the 29 out of the calculator. Left with fractions of an inch, so multiply that by 16. That gives me basically 2/16, which is reduced to 1/8. Right, so divide the top by 2, divide the bottom by 2, I end up with 29 1/8. So the distance from here to here is 29 1/8 based off of our numbers. Okay, so then what we'd have to determine is the projection. So what is P? So we have 2 P's on a strip footing. Okay, so it's the same setup as the top here. So if we know the projection, we have the thickness. Okay, so again, the math is basically in the drawing. So we have 29 1/8 from corner to corner, minus 10 inches and then divided by 2 projections. So it's the same formula, just a little bit different wording. So if I write projection is equal to the footing width, instead of minusing the plate, we're minusing the foundation wall, and then we're dividing it by 2, because we have 2 projections. So 29 1/8 minus the 10-inch wall divided by 2. So we plug that in, so 29.125 minus 10 divided by 2. So we end up with 9.5625, which is 9 9/16. Right, minus the 9, left with the fraction, times that by 16. We get 9/16 as our fraction. So again, the minimum thickness of the footing has to be 4 inches. It's the same for a strip footing. Okay, so our thickness needs to be greater to or equal to the projection, but not less than 4 inches. So in this case, it's not, right? Our projection here is 9 9/16, which then also makes our thickness the same, 9 9/16. So the answer here is the width of 29 1/8, and then we have a thickness of 9 9/16. Okay, I think I'll do this one here, and I might just leave that bottom one. The bottom one's exactly the same as that. This one here is a little trickier, so I'll maybe just go through that one. Okay, that's more of a scenario. So a homeowner wants to get a post move in a basement. The spacing from post to post is currently 10 feet apart. He would like to move the post 2 feet further to allow for a bigger basement bedroom. What is the size of the new pad? So it's a 2-story house, 6-inch plate. So this is a renovation job. So we're shifting a post in the basement, which is then increasing the on-center spacing from post to post by 2 feet. Okay? So that means we're scrapping the old footing, scrapping the old post. That's also going to require us to beef up the beam. Right? So it has a compounding issue. Once we create a wider space between the post, the beam is now not strong enough potentially. So we have to verify that it is. And if it's not, it'd have to be made stronger. Okay, so an engineer would take care of that. We could kind of come up with some numbers and then give that to the engineer, and they could stamp it and approve it and go from there. Okay, so it's a 2-story house, so the initial area of a column footing is 8.1 feet squared. We're 2 feet beyond, right? So 2 feet beyond our 10-foot minimum, which means 10% for every foot, which is 20%. So 20% means 20 over 100. So 20 divided by 100 gives me 0.20. Okay, 2 decimal places shifted. So when I go to do my math here, I'm going to have to go times 1.2. That's my 20% increase, plus including the original number. And that'll give me my new area. All right, so 8.1 times 1.2, that gives me 9.72 feet squared. So now what I have to do is square root that to get the length and the width. So I square root our new area, and that's going to give me an answer in feet. So something that I notice with a lot of assignments is people try to sometime increase this number on the dimension. So you do not increase that onto the dimension, you increase that onto the area. Otherwise you'll get a different answer. So don't multiply the 1.2 by the width. You want to multiply 1.2 by the area. Okay? So then we square root that number. So we end up with 3.1176 as our dimension for width and length. We multiply that by 12 to put it into inches, which gives us 37.412, which is probably 37 7/16. So we'll just subtract the 37 there, because it's written down. That's decimal feet, so we multiply that by 12 to find out how many inches it is. Well, not 12, 16, sorry. So we'll delete that. I can't go back. So let's just start that over. 9.72 square root, square root 9.72 times 12. So I got all my decimals there. Subtract the 37. That's fractions of an inch, right? So not decimal feet. So we multiply by 16, which gives us a numerator of 6, but that's 5 or higher, so I make that 7, right? So it's 37 and 7/16 like I guesstimated. So that's the number we're looking for. So what that means is basically, again, we have a column footing, that this is 37 and 7/16. This is also 37 and 7/16. Now we just have to find the thickness, okay? So we can write that down. That's 37 and 7/16. 37 and 7/16. We know the plate, I guess. Yeah, 6-inch plate. So that means the distance from there to there is 6 inches. So what we're trying to find is, what is the projection? Once we have the projection, we have the thickness as well, long as it's more than 4, okay? So we'll go ahead and get that projection by taking the footing width, which is 37 and 7/16, minus the 6-inch plate, and then we're going to divide that by 2. So to get that fraction there, I'm going to go 7 divided by 16, or I could use the original number there, whatever you'd like, close enough, plus 37, right? So if I don't know what 7/16 is, I go 7 divided by 16, gives me the decimal, then I add on the 37, then I can subtract the 6, and then divide by 2. So that gives me 15.71875, which is 15 and, that's fractions of an inch, so I multiply by 16. So it's 11/16, but that's 5 or higher, so I gotta get 12/16, which is 3/4. So that's 15 3/4. That's 15 3/4. And so is your projection. Okay, so there it is. A few examples there, kind of playing around with 2 column footings, 1 strip footing. I'm not going to bother with the last one yet. The last one's pretty straightforward there. Just a matter of finding your, right, so if it's a 2-story, it starts off as 350, and then look at the criteria. So what is the thickness of the following strip footing? Foundation wall thickness is 10. It's a 2-story building with wood construction and wood siding, so that's basically as far as it goes. So divide that by 25.4. Might as well just finish it off there, take 2 seconds here. So that 350 comes from the code book, right? I'll just maybe slide that over quickly there. So it's a 2-story house. Minimum for 2-story house is 350. And there's no add-ons. It's wood construction, wood siding. So if I just go 350 divided by 25.4, I end up with 13.779 inches there. That's converting it. So that's 13 more than likely, probably 3/4. So I'll go minus 13 times 16. Yeah, so it's 12/16, which is 3/4. That's the footing width. So fairly narrow there, but it's not a very heavy building, right? It's wood construction with wood siding. So a little sketch there. The base of that footing now is 13 3/4. Right, so 13 3/4. We have a foundation on top of it with a 10-inch foundation wall, which probably should be 8 for this kind of construction, but for some reason it's 10. And then we're going to try and find the projection. Right, P. So projection is going to be, see if I get that on me, that'd make it better, eh? There we go. So then if we take the footing width, which is 13 3/4, minus the 10-inch foundation wall, and then divide that by 2. So we know that's going to be less than 4 inches, right? So the answer there is going to be 4 inches. But let's just follow it through. So 13.75 minus 10, and then divide that by 2. So we end up with 1.875, which is 1 7/8. So it means we have 1 7/8 here, and then 1 7/8 here, basically is what we have there. So again, the thickness has to be equal to or greater than the projection. So it's got to be 1 7/8 minimum, but by code, this cannot be less than 4 inches. So we have to say that that's going to be 4 inches minimum, okay? So we have to go with the 4-inch minimum there, because that's a rule. So a strip footing and a column footing has to have a minimum thickness of 4 inches So we start off by looking at projection being the same as the thickness or greater, but minimum 4 inches there. Okay?